In this video, we're going to be doing some exercises about conic sections. Let's start with the first one. We are given the following expression: x squared plus y squared minus 2x plus 4y plus 1 equals 0. The first thing we're going to do is notice that this term and this one depend on x, this term and this one depend on y, and this one is a constant. So we're going to rewrite the expression as x squared minus 2x plus y squared plus 4y, and then this will be equal to, moving the plus 1 to the right hand side, we get minus 1. Now we're going to write this as x squared minus 2x, and in here we're going to add plus 1. And now this expression is y squared plus 4y, and we're going to be adding plus 4. And this, so that the equation still sustains, will be equal to minus 1 plus 1 and plus 4. So now this is a binomial we can write as x minus 1 squared plus this other term is also a binomial, y plus 2 squared, and this equals to minus 1 plus 1 plus 4, which is 4. I'm gonna rewrite this so we have it in color black. And now, if you've seen the previous videos, you can tell that this is a circle. And the general equation for a circle was x minus h squared plus y minus k squared equal to the radius squared, where h and k are the coordinates for the center of the circle. So now from the expression we have, we can say that h equals to 1, that k is equal to minus 2, and that r equals to 2. Then the center of the circle is in 1 minus 2, h and k. With all this information, we can now plot the circle. So the center of the circle is in 1 minus 2. And now the circle has a radius of 2, so it will pass through this point, because this would be the radius. Also, if here is negative 1, then this would be the radius, and so we can form this circle. And this is the circle we were given with the first expression. Now let's move on to a second exercise. In this case, the expression we have is x squared plus 9y squared minus 2x minus 8 equals to 0. Again, we're going to put together the terms that depend on x, those that depend on y, and those that do not depend on any of the variables. This way we get x squared minus 2x plus 9y equals to 8. Now we rewrite this expression as x squared minus 2x, adding 1 here, plus 9y without adding any numbers would be equal to 8, and so that the equation sustains, we have to add +1 on this side as well. So now this is a binomial, so we can rewrite it as x minus 1 squared, and this would be plus 9y equal to 8 plus 1, which is 9. Now we can divide by 9 both sides of the equality to get x minus 1 squared divided by 9 plus y, this was y squared, equal to 1. And this way we get what we know as an ellipse. And the general formula for an ellipse with center in hk was x minus h squared divided by a squared plus y minus k squared divided by b squared equal to 1, where b squared was equal to a squared minus c squared. And this ellipse, we know it's horizontal when a squared is bigger than b squared. So in this case, we have here this number 9, which would be a squared, so then a equals to 3. And now here we have divided by 1, so this would be b squared, which tells us that b is equal to number 1. We also can say here that h would be equal to 1. And from this term here, we get that k equals to 0. So then the center of this ellipse is in 1, 0. Now, using a and b, well, we know that b squared equals a squared minus c squared. And then c squared is a squared minus b squared. And then this is 9 minus 1 is 8. So c is the square root of 8. And once we have c, we can talk about the focuses. The first one would be in h minus c, k, and the second one in h plus c, k. And the reason for this, well, to visualize this easier, we can make a sketch. Let's say we have here a horizontal ellipse with these focuses. This one would be the minus c 0, and this one the c 0. But now we move this ellipse, let's say, somewhere around here. Now, these 2 points are the focuses. Well, from this focus, we had to move h towards the left, so making the x coordinate minus c plus h, and then vertically k units, so the y coordinate would be k. And the same goes for this other focus. It would be first moving h units towards the left, so the x coordinate would be c plus h, and then k units downwards, making the y coordinate k. And this is what we have here. So this equals to 1, that is h, minus square root of 8, k, and k is 0. And the other one would be in 1 plus the square root of 8, 0. And this point here, the 1 minus square root of 8, is approximately minus 1.82. And this one is something about 3.82. And last but not least are the vertex. We know the ellipse has 4 vertex. We have this one, this one, this one, and this one. When the ellipse is centered in the origin, we have the 0b, 0 minus b, a0, and minus a0. Now, this point would be the h, b plus k. This one would be the h minus b plus k. This one would be minus a plus h, k, and this one a plus h, k. And so we have all those vertex points. Minus a is minus 3 plus h, which is 1 and 0. 3 plus 1, 0. 1, and b is 1 plus 0. And this one would be 1 minus 1 plus 0. Now with all this information, we can plot our ellipse. The center of the ellipse was in 1, 0. That is, this point. Now, let's mark all the vertices. One is in 4, 0. The other one is in minus 3 plus 1 is minus 2, 0. The other one is in 1, 1, and the other one in 1, minus 1. Now the focus points are in minus 1.8, that is something about here, and 3.8, so that is around this point. So then the ellipse looks something like this. Now, let's try and do the third exercise. We have the expression y equals 2x squared minus 4x plus 5. We can take common factor 2 from these two terms to get that y equals 2 times x squared minus 2x and plus 5. Now, what we can do is write this expression as x squared minus 2x, but adding plus 1 here. In order for the equality to hold, we have to add plus 1 on the left hand side. So now we have this constant and this one. So we have y minus 4, because 1 minus 5 is minus 4. And this is equals to 2 times this. And this is a binomial, so we can rewrite it as x minus 1 squared. So with this, I'm going to rewrite this equation with black. And now with this expression, we know we have a parabola, because one of the terms is linear and the other one is quadratic. And the general equation for the parabola was, when it was a vertical one, it is y minus k equal to 4p x minus h squared. We have the y minus k here, But here we have a number 2. We need to write as 4 times p. For this, what we're gonna do is write it as 4 times 1/2, because 4 divided by 2 is equal to 2, so the equality still holds. And this way we have something extremely similar to the equation. So now this 1/2 is p. The 4 is k. And h is 1. So now we know that the vertex for our vertical parabola is in hk, that is 1, 4. And again, let's draw a sketch to represent our situation. We have the axis, and let's suppose we were given here a parabola centered in the 0, 0 with this focus in 0, p. Now we have this parabola here, and the focus is, we had to move this one h units, so h in the x-coordinate, and then downwards k units, so p plus k. And the same with the directrix. The directrix was in y equals minus p. Horizontal shifts will not affect the directrix, but vertical shifts will. So now this directrix was moved k units downwards, and it is located in y equals minus p plus k. So the focus points are in h, which is 1, and p plus k, that is 1/2 plus 4. So it's the point 1, 4.5. And the directrix is in y equals to minus p plus k. So it is minus 1/2 plus 4, which is 3.5. And we have now all the information we needed to plot the parabola. The vertex is in 1, 4. The focus point is in 1, 4.5. The directrix is in y equals to 3.5. And now the parabola will look something like this. Let's now do the last exercise. We have the expression 9x squared plus 18x minus 16y squared plus 96y equals to 279. From these two terms, I'm going to take common factor 9, leaving us with 9 times x squared plus 2x. From these two other terms, I'm going to take common factor 16, leaving us with y squared minus 6y. And this all equals to 279. Now I'm going to try and form binomials with these two terms. So for this, on this term I'm going to add plus 1. And on this term I'm going to add plus 9, because 6 is 2 times 3. So we have to put the square of 3. And this will be equal to 279 plus 9 times 1 is 9. And then 16 times 9 with a minus sign is minus 144. So, as we wanted to do, this is a binomial, so we have 9 times x plus 1 squared minus 16 times, again, we formed here a binomial y minus 3 squared, and this will be equal to 279 plus 9 minus 144 is 144. So now what we're gonna do is divide by 9 and by 16, leaving us with x plus 1 squared divided by 16 minus y minus 3 squared divided by 9 equal to 144 divided by 9 and by 16 equals to 1. So we have something very similar to the ellipse, only with a negative sign. And this negative sign tells us we are actually working with a hyperbola. And as we've seen before, the general formula for a hyperbola centered in hk is x minus h squared divided by a squared minus y minus k squared divided by b squared equals to 1, where b squared was equals to c squared minus a squared. Now in this term we can say that h equals to 1. Here k equals 3. So then the center is in 1, 3. This 16 is a squared, so a equals to 4. And this 9 is b squared, so b equals to 3. With this, we can say that c squared equals b squared plus a squared. This is 9 plus 16, which equals 25. And then c equals the square root of 25, which is 5. Again, as we did before, we're gonna do a sketch to see what we're working with. We know this hyperbola is horizontal because the term that has the negative sign is the y term. So if our hyperbola was centered in 0, 0, it would look something like this. But now our hyperbola is somewhere here. So if we have this and this focus, these focuses were in minus c0 and c0. They are now here and here. So this focus had to move h units, leaving the x coordinate as minus c plus h, and then k units upwards, leaving the y coordinate as k. And the same with this one. The h shift would leave the x coordinate as c plus h, and the vertical shift the y coordinate as k. So the focus points, we have one in minus c plus h k and another one in c plus h k. This is c is square root of 5, this is c is 5 plus h, so plus 1, and k is 3. C plus h, this was negative 5, this would be 5 plus 1, 3. So the two focus points are minus 4, 3, and 6, 3. Now let's have a look at the vertices. This point was the point a minus a 0, and this one was a 0. So again, moving it towards the right and then upwards would leave this vertex as minus a plus h k, and this one moving it, we'll leave it here as a plus h k. So our two vertex points would be minus a plus h k and a plus h k. So this is a was equal to 4, so minus 4 plus 1, 3, and 4 plus 1 is 3. So we have minus 4 plus 1 is minus 3, 3, and 5, 3. And last but not least, the oblique asymptotes. They were in y equal to plus or minus b over a for a horizontal hyperbola times x. So it is plus or minus b is 3 over a times x. This is without taking into consideration the shifts. So to plot these asymptotes, we're going to have to do it with starting point instead of the origin. We're going to have to start from the new origin, the new center for our hyperbola. Let's draw it. The center of the hyperbola was in 1, 3, and that is right here. The two vertex points were in minus 3, 3, and in 5, 3. The focus points were in 6, 3, and minus 4, 3. And now we have to plot the asymptotes. To do so, instead of starting from the origin, we're going to start from our center. So now we have to move 4 units in our horizontal direction and 3 units upwards. So from this point we move 1, 2, 3, 4, and then 3 units upwards. So doing the same downwards, because we have the plus or minus, we get these 4 points. And now with these 4 points, we can plot our asymptotes. This is all very approximate, so the lines might not be 100% correct. But with all this, we can draw our hyperbola. We're gonna start from the vertex and move in an asymptotic way through our asymptotes. And then this is the final hyperbola we were given. Now I'm gonna leave you some exercises for you to solve and practice. You have to do the same as we did here with these expressions. Remember that if you're a member in Patreon, you can find not only the boards for every video, but also the solutions for all the problems we give at the end of some of the videos.